let's do a calculation involving isotopes. Remember, isotopes are elements where the number of protons is the same, but the number of neutrons in the nucleus is different. So you have different masses among different isotopes. Here we're going to take a sample of pure carbon and look at the mass spectrum. Now, remember, pure carbon means we take a sample of pure carbon from the ground and we run it through the mass spectrometer. The question is, what is this peak at mass 13? What's the molar mass of the sample? And how many protons and neutrons are in carbon-12? We can go through these initially. The sample is naturally occurring carbon, so it's 1% carbon-13 and 99% carbon-12. And that's reflected in the mass spectrum, a peak about 100 times as big at 12 as you have at 13. So that explains the mass spectrum, the naturally occurring isotope carbon-13. Now, the molar mass is the weighted average of those two isotopes. The ratio in every 100 atoms, there are 99 carbon-12s and 1 carbon-13. So let's just take the average mass of carbon-12. In 100 atoms, you'd have 99 carbon-12s for a mass of 1188. You'd have 1 carbon-13 for a mass of 13. Add those two and divide by the total number of atoms we had, 100. Divide that by 100 and you get a molar mass of 12.01 grams per mole. Now, that is the grams per mole we get in carbon-12 and carbon-13 mixed together in their naturally occurring ratios. Now, how many protons and neutrons in a carbon-12 nucleus? Carbon-12 has atomic number 6, and atomic number tells you the number of protons in the nucleus, and it determines the identity of the atom. Remember, if you know the number of protons, you know the identity of the element. Not the mass, the number of protons. It has mass 12, so those other 6 mass units, 6 for the proton, mass 12, there's 6 more mass units, those must be the neutrons. So there's 6 neutrons in carbon-12 nucleus. And if it's a neutral atom, then there needs to be 1 electron for every proton. So 6 protons, 6 neutrons, 6 electrons in a carbon-12 nucleus.